Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session we'll be talking about HSM's option of pencil milling, parallel pencil milling, and 3D corner offset. We'll first start off on this part using pencil machining. What pencil machining does is that it picks up every single one of these corners over here and does a pass on every single one of those corners, and we'll show you exactly how this is done within the operation. I'll choose the operation in HSM, and the operation that I'll first start out with will be pencil milling. Now the tool that I will be using will be a 4mm ball end mill. My constraint boundaries in this particular case will be this area over here. That means I only want to work within that circular area over there. Now if I continue going down, we go down into our passes, and I first want to start off with having a bitangency angle of 10 degrees. In other words, anything that is less than 10 degrees of a contact point between the tool itself, it will not pick up. Now I'll do save and calculate. And before that, I will go into my links and we'll be working one way, and we'll also be working prefer climb milling. Now, when I do save and calculate, you'll note that there are certain areas that were not picked up in my pencil milling. Now, if I do my simulation, you'll note that the tool will work in specific areas, but it will only work in these particular areas as you see over here. And you'll note that there are areas that were not picked up, such as these areas around here, this area over here, that was not picked up. The reason for that is because the bitangency angle, even though it being 10 degrees, the tool, being a small tool, was not able to have a bitangency angle of this area over here because this radius was too big. So what we can do to compensate for that is simply go into our passes area, and we have this option called overthickness. What overthickness does is takes the tool, and if I were to say add 1.5 millimeters on the side of the tool, all of a sudden the tool will actually be able to pick up those passes, and it'll work in those areas also. Now let's just do save and calculate, and then we'll do the simulation again. And we'll do our simulation, and this time I'll use the 3D simulation, and you'll note that the tool itself will actually work in every single one of those areas. Not only this area and these corners over there, but also it'll work around these parts over here. It'll also work in these areas around over there, as well as every single corner over there. In other words, every single border on this part was picked up. Working pencil machining in this particular operation is not enough. Sometimes I want to do pencil milling, but work a little further out from that area and then work my way in. For that, we have a different option, and I'll base it on my first operation that I've done here. I'll simply do copy of my first operation and then paste. And this second operation that I've created now, I'll change from pencil milling to parallel pencil milling. The tool stayed the same as before, and so as my constraint boundaries. My pencil milling, I'll change this again to 10 degrees with an overthickness of 1.5. But now we have the option of passes, which we didn't have before. And in the passes, I can say I want to go every, say, half a millimeter, or I can even make it even a little smaller than that. I'll even do 0.2 millimeters. And what I can do is I can say, let's limit it to only 5 steps past the part. In other words, if I'm going on a specific pencil boundary over here, it'll only go 5 steps of 0.2 millimeters outside. In other words, it'll start from 1 millimeter outside of the part on both sides of that particular step. Let's take a look at our link area first, and we'll keep it at one way, or we can do bidirectional, and I'll leave it right now at one way. And now we'll just do simple save and calculate, and then we'll simulate our part. And in the simulation itself, again, I'll be using the 3D simulation. You'll note that the tool will work in that area, slowly working its way around. Also in this area, and you've noticed that it worked one direction and now it's working the other direction, working its way in from a millimeter all the way in. And it's now doing it also around each one of those areas on the part itself, clearing every single area from the outside in and from the top out. Now you can see that actually completed every single one of those areas, and every single one of those areas was worked on using the parallel pencil option. Another option we can use here is something called 3D corner offset. Now what 3D corner offset does is very simple. These areas, the best way to work on these areas is with a 3D constant step over. But with a 3D constant step over, I have to usually pick out the boundaries myself. But with the 3D corner offset, we're actually allowing the program to use the pencil milling boundaries that it picks out all by itself and to automatically give me those boundaries and work within those areas using the technology of 3D constant step over. Let's take a look at the operation itself, and I'll start the new operation of HSM. And again, I'll use, like I've said, the option of 3D corner offset. The tool, again, will be a 4mm ball end mill. And my constraint boundaries, exactly the way it was before. In my pencil passes, we'll use the exact same parameters I've used before of giving an over thickness of 1.5 with a bitangency angle of 10 degrees. And in my passes area, I'll use 0.5 in millimeters on every single one of those areas. And in my link area, we'll be working one way. Now let's take a look exactly what happens. In my simulation, when I use my simulation, you'll note that it'll work in every single one of those areas, and the boundaries that it'll be working with will be the pencil milling boundaries that it picked up, and it'll work in those areas using the option of 3D constant step over, boundaries picked up automatically from the pencil machining. Now if we actually look at the simulation itself, you'll note that we'll use, again, this time we'll use the host CAD simulation. And as you see, and I zoom in, it'll work first in this area itself, working in a circular fashion exactly according to the shape of that area itself. The same thing with this top area over here. And in these areas over here, it'll work exactly according to the shape of that particular area itself, going around each part as shown over here, doing that in every single area around the part itself. And now it's working also around the part itself as shown here. And then it will complete every single one of those areas to give you a perfect finish around the entire part. And if we look at it on top, you'll see that every single area is machined according to the shape of that particular area. And now we have a complete part completely machined around. As you see also, it'll also work in these areas over here, completing that area, and also on the walls inside over here. Again, we'll take a look at the top. You'll see now that every single area is according to the shape of that particular area, which is the perfect way to finish off this part, to give you the exact type of finish that you need, as shown over here. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.